Shut that off.
That's fine. Okay. 24, was that the correct question? Was that a graph? Did someone have that question? Was 24 an actual question?
Yes. Yes.
Yes. Okay.
On this?
Yes. Okay, so on 24 we have negative 19 pi 12ths, and we're finding the reference angle. When you're finding the reference angle, you want to see how far away it is from the x-axis. Is it recording? Because that would really suck to be like, I recorded it. Just kidding. So we first want to see how, what quadrant this lies in. So we see how many times 12 goes into 19, which is how many times?
1.
1, and how many is left over?
5.
How many?
7.
7. So we have 1 and 7 twelfths, and it's negative, and we're in terms of pi. So if we draw this, remember when we're negative, we're going clockwise. And so we go to negative 1. Is 7 twelfths more than half or less than half? More than half. So we go to here. So then we want to know how far away from the x-axis. Remember, it's really important that on your reference angles, you're looking for the x-axis. So how far is it from here to here? On radians, you're always looking to see how close to the nearest whole number it is, or how far away from the nearest, well, I should say nearest integer it is, since this one's negative. So this is closer to negative 2, so how far away from negative 2? Well, in order to get 7 to be 12, I have to add 5 more on top. So then our reference angle is 5.12. And remember, our reference angle is always positive. Does that help? Any other questions on that assignment? Okay. So go ahead and just collect that at the tables for right now. I think I'll have time to go around and look at it. So this is not on your notes, so I can't remember if there's a blank back page.
Yeah, there's just a blank back.
You need to turn in the unit circle, or did we already do that?
Oh, we didn't. I'll put up the answers to the unit circle when I'm done with the lesson, and then you can turn that in as well. So that way you know if you did it right or wrong, because that's important. Okay. Today we're looking at 2 different things. We have a property that's talking about even or odd. Have you discussed ever when you've done graphs about if a graph is even or odd? It's not there, so if you want to take notes, just use the back side because it's blank.
I think.
So, even graphs are symmetrical about the y-axis. Odd graphs are symmetrical about the x and y-axis, which we call the origin. So it's symmetrical about the origin. So basically, if you were to fold in half both directions, right, then you would get the same thing. So the technical definition for an even graph is that if you have f of negative x, it's the same thing as f of x. And for an odd graph, the actual definition is if you have f of negative x, it's the same thing as the opposite of f of x.
This right here?
Yeah.
Something just popped up on your iPad.
Oh. Something's at my front door. Moving. So, so your even graphs, if I make a picture, so if we look at our parabolas that we've done lots of times, right? So if we call this x and we call this negative x, notice x and negative x have the same y values, right? I plug in the positive x value and the negative x value and I get the same y value on both of them, right? And then on an odd graph, so one of the odd graphs that we've looked at is a cubed function. the original one without it being transformed. Okay. Oh, that was kind of a bad drawing, but. So this is positive x and this is negative x. Right, well, let's try that picture again. There, that'll look nice and done. You see how at positive and negative x, this is the same y value, but one is positive and one is negative, right? So that's what this part is saying. You plug in negative x, and you get the opposite of f of x, right? So the opposite sign. Okay. So you can always check to tell if a graph is even or odd by plugging in negative x and seeing if you come up with the same equation, or if you come up with the exact opposite equation. Okay? Now our trig functions have even and odd properties with them. So all of them, you also have the option that it's neither of them, right? That's totally a thing. But all of your trig functions originally, without any transformations, are either even or odd. So the only ones that are even are your cosine graphs. Okay, so I guess I'll just go to the next page. So, oh, okay, well I can wait. I just didn't know. So our cosine graph, if you come and you look at our straw picture, right? Notice on our straw picture that we started up at the very top and then we came down and went back up, right? So if we continue that same pattern in both directions, notice that the cosine graph will be symmetrical around the y-axis, which means that it's going to be even. Am I okay to switch pages?
Yeah.
Any no's? So if you take the cosine of negative x, that's the same thing as the cosine of x. So again, if we look at our graph, this is the graph that we drew for the straw activity, but if you continue it on, right, can you see, minus that I can't draw superbly great, can you see that it would be symmetrical across the y-axis? Right? So this means that it's even. Its reciprocal, secant, is also even. So the secant of negative x is the same thing as the secant of x. Okay? All the rest of the trig functions are odd. So I just remember which one's even, and it's reciprocal. And then the rest of them are odd, and then that's a fast way to memorize them. So for your odd ones, we've got sine of negative x is the opposite of sine of x, and it's reciprocal. So over here. So the cosecant of negative x is negative cosecant of x, and then tangent of negative x is negative tangent of x, and cotangent of negative x is negative cotangent of x. So if we look at our sine graph looks like this. Okay. So if we were to fold, the odd means that it's symmetrical about the y and x-axis. So if I were to fold this across the y-axis, I would end up with that picture, right? Can you see that? And then if I were to fold it across the x-axis now, right, so this way, I would end up with this same picture. Okay? So that's what we mean about the origin, that it's symmetrical of both the x-axis and the y-axis. Yes?
What does a tangent graph look like?
Your tangent graph, it's kind of a weird graph. It looks, it has asymptotes, and it's a little bit different than sine and cosine in that the period is just pi instead of 2 pi. But it looks kind of like a cubed, but it's bounded by your asymptotes, and then it continues to repeat itself over and over. So notice, since it's like a cubed, right? If I take this positive x value and this negative x value, it will be the positive, and then the opposite is the negative. Okay. Your cotangent is similar. Your cotangent is also a period of pi, but it's shifted over from tangent, and then it goes the opposite direction, so it goes like this. That was a horrible drawing, just work with me. So, and then we'll get to your
We need to
secant.
know the cotangent graph.
No, I just he asked, and so I was showing a visual, but albeit in the not great one, but it's the general idea. So what happens is we can use this to help us evaluate the unit circle. We can also use it for other things when we're doing things later on, which we'll get into more later. But what we're doing today is just with the unit circle. So for example, if I tell you to rewrite using the even, odd functions, and then evaluate, and I give you the sine of negative 210 degrees. So first of all, is sine even or odd?
Sine's odd.
Yeah, sine is odd. So that means that it's the opposite of sine of the original number, right? So this is the same thing as the opposite of sine of 210. Right? So this is what we're using. We're saying that f of negative x is the same thing as negative f of x. This is what being odd means. Right? It's that same thing we just wrote on the previous page. Sine of negative x is the opposite of sine of x. Right? That's because sine is an odd graph. Has odd symmetry, I should say.
What do we use this for?
We're using this currently to do evaluate on the unit circle. So now instead of drawing a negative angle, we can draw a positive angle and then evaluate with a positive angle. You also know how to evaluate with a negative angle. Right? It's just using the even and odd functions. We'll also use the even and odd functions later when we're looking at various identities, and you use it to manipulate identities. So here, if we want to find the sine of 210, we're going to go to 210. So 210 is here. The reference angle, remember, is always to the x-axis. So we have from 210 to 180. So that means that our reference angle is 30 degrees. So if our reference angle is 30 degrees, again, we're going to put down our 30-degree finger. So remember, you have 0, 30, so that's your pointer finger. Okay. So remember, the fingers represent the top number in a root, and then everything is over 2. So this point that's on the edge of the unit circle is really square root 3, everything is over 2, and then square root 1, but square root 1 is just 1, everything is over 2. But we know we're finding the sine. The sine is the y value, we're going to take the y value. Before we take the y value, we have to check our signs, like positive, negative signs. So we went left and down, both of which are negative. So we're going to have the opposite from right here, and then the sine of 210 is the negative 1/2. So negative, negative 1/2 is a positive 1/2. Does that make sense?
Yeah.
Now, if, just to show you that these two things are equal, if we were to find the sine of negative 210, negative 210 puts us here. Again, it's 30 degrees, so we get the same point, except for our signs are different. This one's still negative, but this one's positive. So we take the sine, which is the y value, so 1/2 equals 1/2. So, if we take the cosine of 5 pi fourths, oh, negative 5 pi fourths, sorry, I forgot, that's for doing negatives. My fault. So the cosine of negative 5 pi fourths, cosine is it even or odd?
Even.
It's even, which means that it's the same y value. So we have the cosine of 5 pi fourths, that y value is the same value, y value as cosine of negative 5 pi fourths. So now we're going to evaluate the cosine of 5 pi fourths. So 4 goes into 5 how many times? Once. How many is left over? 1/4. So this is 1 1/4 pi. Right, remember that halfway around is pi. 1/4 is less than a half, so we're not going into the fourth quadrant. Okay. So our reference angle is pi fourths. Again, remember your reference angle is always, first it's always an acute angle, less than 90, and it is always positive. Okay. So pi fourths goes with what in degrees?
45.
Yeah, 45 degrees. So we put down our 45 degree finger. So we get square root 2 over 2, square root 2 over 2. Okay. We went left and down again. So both are negative. But we're looking for the cosine. The cosine is the x value. So we're going to take negative root 2 over 2.
Why isn't it positive?
We went left, which is negative. And you're only taking the x value. If I were doing a tangent and taking both, then it'd be positive. But since I'm only taking the x value, then it's negative. Yeah.
Are we also going to be putting these into graphs? Because you just showed us what some graphs look like. So are we going to be applying this to graphs?
Later. Not this chapter, but later, yes. Later. Okay. So if I give you the cotangent of negative 1020. So first of all, we're rewriting it with our even and odd functions, or even and odd identities. Okay. So the cotangent of negative 1020, oh, that's not what I wanted to say, is cotangent even or odd?
Odd.
Odd, right? So that means that this is the opposite of the cotangent of 1020. I suppose I should put my degree sign. So now we need to know how far 1020 is past 360. So I know 360 and 360 gives us 720. So I subtract 720 and I get 300. So we're going to go around 2 full times and then to 300. So 1 full time, 2nd full time, to 300. Thinks I try real hard. Okay. Again, our reference angle is how far from the x-axis. So this is 60 degrees. Okay. 60 degrees is your ring finger. So again, the fingers are the tops in a root, and then everything is over 2. When you're doing tangent and cotangent, you can ignore the over 2's part, right? Because they'll cancel out, and just take the top of the x's and y's. Since it's cotangent, tangent is normally y over x. So that means that cotangent is x over y. So if I take the top of the x, that's going to be the square root of 1, which is just 1, over the top of the y, which is the square root of 3, which we know, hopefully by now, rationalizes to root 3 over 3. Okay. And then I check my signs. Since we used both x and y, and we're in the 4th quadrant, remember the other way that you can check your signs is you can do all students take calculus, right? So in this quadrant, cosine and its reciprocal are positive. Well, we're not finding cosine or its reciprocal, so that means it has to be negative. Or you can do, we went right and down, so the y value is negative, so either way you end up with negative. Does that make sense?
But have we plugged that into the cotangent negative yet?
Yeah, I did at the very beginning. Oh, no, sorry. I understand what you're saying. So then we have this was the cotangent of 1020, so we're doing the opposite of negative root 3 over 3, which gives us positive root 3 over 3. So this was the cotangent of 1020, right? But our real question is we're taking the opposite of the cotangent of 1020. Does that make sense? Can I have nods? Ready with me? Okay. So we also have that we can rewrite it using the fact that there are coterminal angles. So just like we were talking yesterday that, yesterday? Yeah, it was yesterday. When we were talking about sine, cosine being cyclical, that it repeats itself over and over, right? And that one cycle is a period, right? So when it's cyclical like that or has periodicity, then you can use that to rewrite and rewrite it as a coterminal angle that's in between 0 and 360 or 0 and 2 pi. So if I want rewrite as an equivalent expression with the angle between 0 and 360. I guess just, well, whatever. And 0 and 2 pi. And then evaluate. Right, so if I were to give you the sine of 510, so what I want to find is an angle that's in between 0 and 360 that is the same angle as 510. So remember, when angles start and stop in the same spot, we call that what? Yeah, we call that coterminal, right? Right, because they're with the same ending, terminal meaning ending, co meaning with the same ending. Right? So I want something that's in the same spot as 510. So what I'm going to do is I'm going to take 510 and I'm going to subtract 360 until I get something that's between 0 and 360. So if I do 510 minus 360, that gives us 150. Okay. So this is the same thing as the sine of 150. Right? So we're writing, so this is the part where we're writing an equivalent expression that has the angle between 0 and 360. And then we're going to evaluate the sine of 150. So the sine of 150 and the sine of 510 are the same thing. Remember how we talked about the tangent, no, not what I want to say. The trig values are the same for all coterminal angles, right? So these are equivalent. So if I want to find the sine of 150, 150 is here. Again, your reference angle goes to the x-axis. So if this is 150 and this is 180, that means our reference angle is what? 30 degrees. So then we put down our 30-degree finger. Right? Again, the fingers represent what's on the top of the fraction in a root, and then everything is over 2. So hopefully you're getting to the point where you're quick enough now that you don't have to write down the full point, and you're just taking either the sine as the y or the cosine as x and tangent is y over x, right? So the sine is the y value, so I'm going to get the square root of 1, which is just 1, and then everything is over 2. If you're using the all students take calculus, well, I'll explain it. All of them are positive here.
Can you just use the other way to simplify?
Yes. Sine is positive here, tangent's positive here, cosine's positive here. And they're reciprocals, right? So cosecant would also be positive here. So since we're landing in the second quadrant, the sine and its reciprocal are positive. So since we're in sine and we're finding sine, it has to be positive. Or you can think the y value is going up, so that's also positive. So if we do the cosine of negative 17 pi thirds. So again, we want an angle that's in between 0 and 2 pi. So this is a negative angle, so we're going to be adding 2 pi. And we're adding 2 pi because that's what 1 revolution is in radians. So we're going to add 2 pi until we get to something that's in between 0 and 2 pi. So if you do negative 17 thirds plus 2, that gives you negative 11 thirds, which is negative 11 pi thirds. We have to add, bless you, another 2 because it's still negative. So I guess I should do negative 17 pi thirds plus 2 pi is negative 11 pi thirds. And then we have to add another 2 pi.
So the 2 pi is just one rotation?
Correct. So when I add it, something between 0 and 2 pi. Something that's positive and not past 2 pi, basically. So here, really you're just adding, right, because you're adding 2 pi, so you're really adding 6 pi thirds. So negative 11 pi thirds plus 6 pi thirds is negative 5 pi thirds, right? But again, that's still negative. That's not in between 0 and 2 pi, so we have to add another 2 pi.
Why'd you go for negative 17?
Because this is really
Is it
6 pi thirds when you get a common denominator. So then I'm doing negative 5 pi thirds plus 6 pi thirds, which finally gets us to a positive answer of pi thirds. So this is the same thing as the cosine of pi thirds. Because negative 17 pi thirds and pi thirds are coterminal angles. So we take pi thirds. Pi thirds is 60 degrees. We're in the first quadrant, so it's just 60 degrees. So we put down our 60-degree finger. We take the left side, because that's cosine, which is also our x value. So we're going to have the square root of 1, which is 1, and then everything is over 2. We're in the first quadrant, so everything is positive anyways, so it's positive, or you went right, which is positive, so it's positive. So this would be, both of these would be your answer, right? This is the rewriting the equivalent expression, and then this is the evaluating. Victor?
No, I'm stretching.
Oh, okay. Just kidding.
Wait, so all we have to do is write
You're rewriting an equivalent expression where the angle's in between 0 and 2 pi or 0 and 360. So in this
That's
case,
easy.
I want something that's in between 0 and 2 pi because we're in radians, right? So I kept adding 2 pi until I found something that was in between 0 and 2 pi.
Okay.
Right, so a positive coterminal angle, basically. That's less than 2 pi. And then I evaluated that function, so the cosine of pi thirds, knowing that both of these will be the exact same, because again, they're coterminal angles. Right. Does that help? Okay. Let's try one more. Let's do, oh, we already did a sine, didn't we? What else did I do?
Choose the cotangent.
Sine, yeah, we can do a cotangent. Negative 750.
But don't those go by pi, not 2 pi?
The period is pi,
Yeah.
but
So would it need to be between 0 and pi?
no, we still are going 0 to 2 pi.
Okay.
It's fine.
So the cotangent is -50%.
Negative 750. So the cotangent of negative 750. Oops. So we know that negative 750 is past negative 360, so we're going to take negative 750 and we're going to add 360, which gives us negative 390. But that, again, is still negative, so we're going to add another negative 360. No, not another negative 3, just to add another 360, which gives us negative 30. That's still negative, so we still have to add another one. So we add 360 here, and what does that leave us with?
330.
330. So This is the same thing as the cotangent of 330 degrees. So we're going to do 330 is in our fourth quadrant. We find our reference angle. From 330 to 360 is just 30 degrees, so our 30 degrees. So our reference angle is 30 degrees. And we're going to put down our 30-degree finger. We're doing the cotangent, so we're doing x over y. So I'm going to do root 3 over 1. I'll just go down here. Root 3 over root 1, which is just root 3 over 1, which is just root 3. We're in the fourth quadrant, so again, we went right and down. So that means that our y value is negative, which makes the whole thing negative. Or you can do, all students take calculus, so only the cosine and its reciprocal are positive in the fourth quadrant. We're not finding the cosine or its reciprocal, so then it has to be negative. Does that make sense? Okay. I'm going to give you your assignment.